Okay, today we're talking about starting with chapter 3, and we're talking about number theory, prime and composite numbers. Don't get scared off by all the number words on the page because it's a lot less than what's in the book. If you want to read more, I encourage you to go to the book. So I tried to skim it down to the bare minimum to make sure you knew what you needed to know to move forward. So first off, we have our set of natural numbers. Natural numbers, also referred to as counting numbers. Okay, one all the way up as high as you can count, which we usually refer to that as infinity. Okay, we have to talk about divisibility. So the three ways that you need to realize that this can be said is A is divisible by B. B is a divisor of A, or B divides A. Okay, all of those ways of saying it are symbolized by writing it like that. So that's a B first, vertical slash, and then an A. And so I gave you this study tip because I need you to be careful and make sure that you understand. Do not confuse the notation of B vertical A with B slant A, because the B vertical A means B divides A. But the B slant A means B is divided by A, which a lot of times y'all are writing fractions like that. So keep in mind that when it's horizontal, that we're talking about whether or not B divides into A without any remainder. That's what makes it divisible by, a divisor of, or divides it. Keep in mind also that the words factor and divisor mean the same thing. So A is a factor and a divisor of 24. So continuing our rules, our divisibility, we're going to go through the rules of divisibility that hopefully you have heard before, and we're going to discuss them now. Do you have to memorize them? It just makes your life easier. You've got a calculator to use, but you'll see as I go through, if you remember the rules, how much faster things can be. So first off, if you have 2, we look at the last digit of any number. You can't read that very well. So the last digit, if the last digit is 0, 2, 4, 6, or 8, then we know that the number, it's also known as an even number, and that means it's divisible by 2. This number is divisible by 2 because the last digit is 0, 2, 4, 6, or 8. Okay, to find out if a number is divisible by 3, then we look at the sum of the digits to see if it is divisible by 3. And sum, remember, means to add them all up. So this number is divisible by 3 because when I add up 5, 2, 3, 4, and 1, I get 15, and 15 divides by 3 evenly. Okay? For 4, you look at the last 2 digits to see if it is divisible by 4. So I have this really large number, 3,947,136, and I want to know if it divides by 4. All I have to do is look at the last 2 digits. 36 is divisible by 4, so I know that this really large number will be divisible by 4. How do we know if something divides by 5? If the number ends in 5 or 0. Okay, the rule for 6. The number is divisible by 2 and 3 because 2 times 3 is 6. So when you look at a number, if it's an even number and divisible by 3, you know it's got to be divisible by 6. Okay, for 8, it's similar to 4, but instead of the last 2 digits, we look at the last 3 digits. Okay, 832 would all you would need to know if 8 goes into 832, and it does. Okay, so that's something you can use again, use your calculator. 9 is similar to 3, and that is the sum of the digits have to be divisible by 9. 10 is the last digit has to be a 0. So if it ends in 0, it's divisible by 10. And lastly, we have 12, and that is if the number is divisible by 3 and 4. Okay, again, 3 times 4 is 12, so if they go into both of them. So if it's not on this list, as in we skipped 7 and we skipped 11, the rules of divisibility aren't worth memorizing. So let's go do some examples. Use the rules of divisibility to determine whether each number given in the exercise is divisible by each of those. So it's the same thing we had in our chart. So if I start with this first one, okay, 7, 2, 4, 5, I'm going to look at it and I'm going to say, I'm going to go in order, okay? Is it divisible by 2? No, because it's not an even number. 3, I'm going to add up the digits. What is the sum of these digits? 7 plus 2 is 9, plus 9 is 18. Is 18 divisible by 3? Yes, it is. So that's divisible by 3. If 2 doesn't go into the number, you don't have to worry about 4, 6, 8, 10, or 12. So the only two we have left to worry about are 5 and 9. Does 5 go into the number? Yes, because it ends in a 5. 9, does 9 go into 18? Yes, it does. So 3, 5, and 9 are the only numbers that go into it from our list. Okay? 21,408 is an even number, so I know that 2 goes into it. I need to add up my digits. They add up to 2 plus 1 is 3, plus 4 is 7, plus 8 is 15. So the sum of my digits is 15. And does 3 go into 15 evenly? It does, so that means it goes into the number. With 4, I'm looking at the last two digits. Does 4 go into 8? Yes, it does. Does 5? It doesn't end in a 5. 6. Do I have 2 and 3 in my list? I do, then I have to have 6. 8. 8, I'm looking at the last four digits. 408. Use your calculator if you don't know, but 8 goes into that number because 8 goes into 40 and 8 goes into 8. So we have 8. 9 looks at the sum. 9 doesn't go into 15 evenly. 10 doesn't end in a 0. 12, I have 3 and 4 on my list, so I'm going to have 12. So that was probably a little bit faster than had you divided each of those with your calculator to give an answer of yes or no, but you're more than welcome to do that. 26,428. First thing, again, ends in an even number, so I know that 2 goes into it. I'm going to add up my digits. The sum is 2 plus 6 is 8. 2 plus 8 is 10. So I have 10 plus 8 is 18 plus 4 is 22. So these add up to 22. So that means I know 3 and 9 are not going to go into it. Does 4 go into it? Does 4 go into 28? 4 goes into 28 7 times, so 4 is good. 6 won't work because I don't have 2 and 3. 8. Does 8 go into 428? It does not. 9 does not go into 22, so it's not. 10, it doesn't end in a 0. 12, I don't have 3 and 4, so the only sums I have are, the only factors are 2 and 4 of these that we have in our list. Okay, last example of that, 374,832. Again, the first thing I'm going to do is look at the sum. So 3 plus 7 is 10, 4 plus 8 is 12, 10 and 12 is 22, 22 plus 5 is 27. So it ends in an even number. 2 goes into it. 3, 3 goes into the sum of 27, so it works. 4, last two digits, 32 is divisible by 4. 5, it doesn't end in a 5. 6, I have 2 and 3 in my list. 8, does 8 go into 832? Yes, it does. 9, does 9 go into 27? Yes, it does. 10, does it end in a 0? No. 12, do I have 3 and 4 in my list? So there we go. So you get to do that, practice some. The other thing that you'll have to do with divisibility is they say use a calculator to determine whether each statement is true or false. If the statement is true, explain by using the rules. So if I look at 34, I'm going to say that says, does 3, basically it says, does 3 go into this number evenly? Okay, is 3 a divisor of it? So all I have to do is add up the digits because that's the rule for 3. 8 plus 1 is 9. 9 plus 6 is 15. Does 3 go into 15? Yes, it does. So I'm happy with that explanation. You can tell me because the sum equals 15. Okay? 35. 4, does that divide evenly into 10,612? I'm looking at the last two digits. Okay? Um, and 4 goes into 12. It does. So this would be true. And your reason you can say is that 4 divides 12 because those are the last two digits. 5, does it go into 38,014? I hope everybody knows that's false because the last digit does not equal 5 or 0. And again, does 5 go into that one? Again, false. Same reason that we just gave. Okay? Alright, one more thing we got to talk about, or a couple of things. Prime factorization. Okay, it's an important thing. It can simplify your life in a lot of ways. But a prime number is a natural number greater than 1 that has only itself and 1 as two factors. So this says that it has exactly two factors. That's kind of a shortened version of what we just said. Now, it's important for you to know those. So I'm going to list the first couple of prime numbers, actually more than the first couple. 2, the only even prime number. 3, 5, 7. So I don't have to worry about any other even numbers because they're all divisible by 2. 9 is not. 11, 13, 15 is not. 17, 19, 23, 29, 31, 37. Okay, I think we're good from there. You got the idea. A composite number is a natural number greater than 1 that is divisible by a number other than itself and 1. So basically anything that has more than two factors. Okay, this one will have more than two factors. Okay, and if you want to go in order, okay, again, these numbers have to be greater than 1. So the first one is going to be 4, and then you've got 6, 8, 9 would be that first odd one, 10, 12, 14, 15. I think y'all got the idea there. Okay, so one thing to remember, as it said, each of these has to be greater than 1. So keep in mind that 0 and 1 are neither prime nor composite. Okay, now before we go into it, one of the things that to finish our prime factorization, okay, you need to keep in mind that every composite number can be expressed as a product of prime numbers. That's what the Greeks came up with. They didn't have the video games and the cell phones and the TV and computers and everything else to distract them. So they came up with our fundamental theorem of arithmetic. And it does make life easier when you can find the prime factorization of numbers. You'll see as we continue through the lesson. But I'm going to show you a new method of doing it in your book. Okay, they show you how to do factor trees, and you are welcome to do factor trees. I just think it takes up a lot more room, and especially when we get into the second part, it's a little bit longer, and I find a lot of people make mistakes with it. So I like to use something called division by primes. Mine is going to be division by primes. So when I do a problem, 75, I'm going to start off with, I'm going to go over here and say 75. And I'm going to start off with always the first prime number. So it means that when I do it, I'm going to start with 2, 3, 5, and 7 and go forth. Does 2 go into 75? It does not. Does 3 go into 75? It does 25 times. 3 doesn't go into that number, so then I'm going to go to 5. And use your calculator to divide this off. You can't do it in your head. Does 5 go into 25? It does 5 times. And so now you notice that I have all prime numbers on the outside here. Okay, that is my prime factorization. Okay, it would be 3 times 5 times 5, but we're big people now and we're going to use exponents. So I gave you a little review down here of exponents. Remember that when you use exponents, the exponent tells you how many times it appears as a factor. So this would be written as 3 times 5 squared. And that's how you want to write your answer. And this carries on with the fundamental theorem of algebra, but let's go from there. Um, so the next one that we have would be 56. So I'm going to start with 56. That's the text message. Um, 56. Does 2 go into 56? It does. 28 times. Again, even number, divisible by 2. 2 goes into 28 14 times. Again, even number. 2 goes into 14 7 times. I've gotten to a prime number, so there's my prime factorization. So this would be, how many 2's do I have? I have 3 of them, and I have 1 7. So that is my prime factorization. All right, let's look at 8316. I wanted to do a big one so you can see how long this could go on. I'm going to start down here. 8316. It's an even number. 2 goes into 8 4 times, goes into 3. Use your calculator if you can't do this with your head, y'all. 15 and 8. 4158. Even number divides by 2. 2 goes into it. 2 0 7 9. So 2 doesn't go into it anymore. I need to see if 3 does. And when I add up those digits, they add up to 18. So I know 3 goes into the number. And 3 goes into that number 693 times. Again, add up my digits. 3 goes into the number. 3 goes into it 231 times. Again, add up the digits. 6. 3 goes into it again. And 3 goes into that 77 times. So 3 doesn't go into it, so I go to the next prime number. 5 doesn't. 7 does. And 7 times 11. So this is my prime factorization. So I have a 2. We always write these in order. I have 2 2's. I have 1, 2, 3 3's. I have a 7. And I have 11. Okay, so just to highlight that, I want you to see that these numbers here, if it'll let me do that, are how we get our answer. These numbers here, how we're getting, that was kind of big. Let's go with stay in the box there. And then all of these numbers, oh, it didn't like that because I didn't curve enough. Come back. All of these numbers are what give us that one right there. So that's how you're getting the answer. Okay, so 2 quick problems to show you how to apply that to finding the greatest common divisor. Greatest common divisor, also GCF, greatest common factor, and LCM. Okay, so when you do your homework problems, you'll see that I gave you the same problems. So I really only have 2 problems here. I'm trying to find 72 and 20. I want to find the GCF and the LCM. And then 224 and 430. Again, want to find the GCF and the LCM. So if I start off with 72 and 20, watch how we do this at the same time. Does 2 go into both of those? It does. 2 goes into 72 36 times, into 120 60 times. Does 2 go into both of those? It does. 2 into 36 is 18. 2 into 60 is 30. Again, still 2 even numbers, so 2 goes into them. 2 goes into 18 9 times. 2 goes into 30 15 times. All right, 2 doesn't go into both of those. Does 3 go into both of them? Yes, it does. 3 goes into 9 3 times. 3 goes into 15 5 times. These have nothing in common. Okay? When you come down to two numbers that have nothing in common, okay, the only common factor is 1, then those two numbers are called relatively prime. Okay, so the key here is what is your GCF? Okay, and when you do it like this, okay, and you've done it in common, all the numbers on the outside, I thought it might do that. Let's see if I can make this. The numbers on the outside part are your GCF. So my GCF in this case is going to be 2 times 2 times 2 times 3, which is 24. So we found the GCF by multiplying all those numbers on the outside, and the numbers that you have left actually doesn't matter. I don't want that. I want a different color so you can see. It doesn't matter if they're prime or not. The fact that they have nothing in common means that there's no that's going along with our greatest common factor and least common multiple. So in this particular example, to find our LCM, we're going to take that greatest common factor of 24 and multiply it by what's left. So 24 times 3 times 5 with your handy dandy calculator is going to be 360. Okay, I'm going to do one more example. I know it's a little bit long, but I think it's important for you to see. So 224 and 430. So they're both even numbers, so I'm going to divide them by 2, and I'm going to get 112 and 215 when I divide those. They're not both even, so 2 doesn't go into them. I would go to 3 next. 3 doesn't go into that number, so I don't need to worry about this one. I don't need any other even number, so I would go to 5 next. 5 doesn't go into it. I probably would go up to 13. 5, 11, 13. None of those numbers go into it. So we stop here because these two numbers are now relatively prime. So my GCF in this case is the only number on the outside, which is 2, and my LCM is going to be 2 times 112 times 215, which is 48,160. Okay, so if you're in my class right now and finishing this video, I want you to fill in the blank and tell me what relatively prime numbers are. And your answer would be two numbers whose only common factor is the number 1. Thanks, and come see me if you have any questions.